So in the last video, we introduced you to the idea of how statistics models are going to be different than what we learned in algebra class. So let's first talk about how they're a little bit similar, and then what our goals of this rest of this chapter is really to do. So what we're going to have is we're going to have two variables, and think of those as your x and y that we had in algebra class. We're going to have our response variable. That's going to be our y. And then we're going to have an explanatory variable, and that's going to be our x. But let's also more specifically define what I mean by a response variable and explanatory variable. The response variable is going to be our outcome of interest. The one that we really want to predict. And the explanatory variable, or our x, is going to be thought to partially explain this response variable. So in the very first video, we talked about a few examples of where we were talking about trying to model one quantitative variable based upon another. So for example, we wanted to know, well, how does the number of customers at a restaurant impact its sales? Well, sales is what we'd really want to know, so that would be our response variable. And then our number of customers would be our explanatory variable, so that would be thought to explain why our sales are what they are. Our overall goal of Chapter 4, so this set of notes we're working on, is to investigate the relationship between x and y. And we're going to do that in three different ways. First, we're going to talk about scatter plots. And the goal of a scatter plot is just to visualize the relationship between x and y with a graph. So just as we had appropriate plots to look at for a categorical variable and a quantitative variable, if we have two quantitative variables, the kind of plot we're going to do, or graph we're going to do, is called a scatter plot. Then we'll move on to regression, whose ultimate goal is to actually predict y for a given x. So for example, if I have 15 customers come in the next hour, what kind of sales do I expect to have? So we can do that through what's called a regression. And then finally, we're going to talk about correlation, which is going to measure the strength and direction of a linear relationship. So there may be a relationship, but how strong is that relationship? Now first, let's make sure we're all familiar with when I say linear. So linear, we're talking about a straight line relationship. So we're going to go ahead and talk about scatter plots in this video. So when it comes to scatter plots, there's going to be different questions that we want to ask compared to other graphs we've looked at in the past. So there's going to be 4 questions that I'm going to ask. The first one I'm going to ask is if the pattern is even linear. So does there seem to be that straight line relationship? Or another way you may hear me ask this, does it not look curved? Because, I mean, at first when we're so used to algebra class and everything perfectly being on a straight line, we feel a little bit more uncomfortable with saying something is linear. So when I say, okay, is it linear? I might say, well, it doesn't seem to be curved, therefore I'm going to say it's a linear pattern. Second, I'm going to look at this, see if the slope looks positive or negative. That's going to be an important aspect for what kind of relationship is going on between x and y. Next, I'm going to look to see how strong the relationship is. And by here, we're looking at sort of the closeness of the points. We will also eventually talk about correlation, which is a measure of strength, but we're also going to talk about looking at strength just from a plot itself. And then finally, just seeing if there's anything unusual. And this, of course, could include outliers that we've talked about before. So we're going to start by just looking at some graphs to understand what we're looking for in these scatter plots. So looking at both direction and linear pattern, so are kind of our first two questions here. So I'll actually do the linear pattern ones here first. So looking at these graphs, we're just trying to see if a straight line would be reasonable on that graph. So looking at this first one, again, straight line seems pretty reasonable. So I would call it linear. Again here, this one doesn't have as many points, so it may be harder to feel comfortable, but I don't really see a curved relationship here. Therefore, I'm going to call it linear. With this last one, if I were to try to connect these dots, I would definitely have this curve that I'd want to put on it, so it's not going to have a linear association. Now please notice with this graph though, there is definitely a pattern with my data. It's just not a linear pattern. We are only going to talk about how to deal with ones that are linear. So we will not end up dealing with this kind of plot in our class. Now when it comes to the positive or negative, we're just talking about that slope. So we already know that these two graphs were linear. So if I put a straight line on there, this first one would have a positive slope. The second one here would have a negative slope attached to it. Which would mean then for this one, as x gets bigger, y also gets bigger. Versus a negative association tells us, well, as x gets bigger, y gets smaller instead. And we will be interpreting slope, so understanding that as one gets bigger, the other gets bigger, versus as one gets bigger, the other gets smaller, will be showing up in our interpretations. Now, probably a little bit harder is talking about strength. So kind of first going through the first two questions with this one, it definitely seems like a straight line relationship. There's definitely not a curve there. It would have a positive slope to it. If I think about putting that line on my graph, those points would be pretty darn close to that line. That was what I call a strong association or a strong relationship. Looking at the other extreme over here of a very weak relationship. So here's one where would you say it's linear? This is one where it's easy to say, well, it's not curved, so I guess linear is okay. What kind of line would you put on here? It'd probably be a pretty flat line. So is it positive or negative? Well, there's not even really, it looks like a slope of 0, right? So there's really not much going on of a pattern in this graph at all. Now we will talk about correlation as a numerical measure of strength because plots can be subjective. And they can be just subjective in the sense of just thinking about what I could even do here of zooming in on a graph. Right, so now my points might look farther apart than when I was zoomed out, and now they look a little bit closer together. So we like to have a numerical measure of strength, not just my subjective looking at a picture idea of strength. Finally, I have a couple of ideas of what unusual features might look like. I'll start with the one on the right here because you're probably more familiar with the idea of outliers. So if I were to say there were outliers on this picture, I'd probably say that one over there was probably an outlier, and possibly those two up there as well. Because overall, it seems that this is sort of my positive slope pattern, but these have sort of this opposite relationship happening. So those points, I'd want to go back and double check, make sure I entered them correctly, make sure they're part of my population. So for example, if I'm looking at undergraduate students, I didn't accidentally sample a faculty member or something like that. So kind of just ways of checking our points. Over here, we have one that looks at subgroups. So what we're actually looking at here, if you can read your own graph, is this is the height of someone and then their hand span. And then what's happened here is I've color coded them based upon if they are male or female. And so what you can see is that, well, women tend to be shorter, so that's why they're more on the shorter end of height. And men tend to be taller. So you can kind of see this clear separation of the two different colors, meaning that, well, gender might also be something that's explaining what's going on versus just looking at height and hand span. So that's looking at some graphs, some scatter plots here. We will also show you how to get those in StatCrunch. But in the next video, we're going to talk about making sure we also know how to use our intuition when we know what should be happening with our data.